Okay, so linked node or linked queue. It extends queue finish. Okay, so private class E has an E data. That's a private E data and a private linked node E next. Now, E brief. I'll show you the answer to both of them, but basically the same answer. You just, when you have doubly linked load, you have to keep track of a little more of the pointers. And then if we say it's circular, we'll deal with that too. So, assuming that add is implemented, right? The easier or maybe easier way, try add E, but then we need to catch the, what does it throw? Legal state exception or else, and this is return. So that's the, I don't know, less character way, right? I didn't type as many characters. But the other way is basically, we have to consider two cases. The first case is if there's nothing in the linked list, so front and rear are null. So if, I need to create a front and rear, don't I? Private linked node E front, which points to the front, private linked node E rear, and a private int size. And then, just for jollies, public linked queue front equals null, rear equals null, size equals 0. And I'll be good. This okay, so that's my constructor. Was it Alt Option J? Whatever the keystroke is. Okay, so back to our add, or excuse me, our offer. So if there's nothing in the queue, what is rear.next? It's a null pointer exception because rear doesn't point to anything. So if front equal to null, or you could say or rear equal to null. You could do either one because an empty queue, front and rear will be null. Yes? Size is 0. Right? What you're doing is you're checking, right? We're checking to see if the queue is empty. Any one of these three cases, all three of them together, doesn't matter. Now, if that's the case, we need to create a new node. Well, we have to create a node every time, but so linked node equals new node.data equals e, node.next equals null. To be completely and totally paranoid, I initialize everything. Now it turns out that if I don't initialize node.next, it will be null because the constructor Java by default, if you don't say what the thing is and it's a reference, it's null. So we say, I saw a lot of people say rear equals node. You say front equals node. And potentially you could say size plus plus. When we have only one node, or front equals rear, same thing. When we have only one item, front and rear point to the same thing. So I could say front equals node or front equals rear. I could swap the order. Right? I could say front equals node, rear equals front, or rear equals node, and I increment the size. If I increment the size here, then I need an else, right? Because I don't want to do, this is if it exists. So rear dot next equals node, right? And then rear equals node is one way of doing it. Or you could say rear equals rear dot next. Right? They both point to the same thing. So I move rear over. And then lastly, size. Right? And then at the end, return true. Now, what I could have done is done this. Right? But since it's the same code, why don't I pull it out of the if-else statement? So I pull it out of the if-else statement. And then I could put the size plus plus outside too. I could do that also. Is that a semicolon? Now, I could make a private method. There we go. So, I like pulling out my common code and putting it once because having duplicate code is often a good chance for causing problems, like we were saying earlier. If you duplicate the code and then find out it's wrong, you got to remember every place you duplicated it and fix it every place. Now I only have one place to fix it. But that does require you to actually follow the logic down correctly through here because we need to make sure that we have the if-else. Right? Because I could put the return true in each of the if clause or the else clause also. But I'll pull that out. Are there any questions on the offer? Now, if it's a doubly linked list, what do I need to do? So in this case, right, I'm adding the first node. What do I need to do? Node dot next is what? Null. Just to be totally, node dot previous equals, yeah, that's just, and notice I got the red squiggly. And I have noticed, not a lot of people, but there are some people still run the writing on a piece of paper. They use a double equals for assignment and sometimes use single equals for testing whether they're equal. So just something to catch. Now if it's a circular linked list, what do we do for node.next? It's front or right? Because front points to node. And what do we do for previous? Rear or so now if it's a doubly linked list here, what do we need to do? Right here, I gotta say node.previous equals rear. And I gotta do that before I move rear. Right? If I move rear, I've just lost hold of that previous node. Right? So I might node previous or rear. I add my new node, right? So I say rear.next is now pointing to the new node. If I move rear, what points to this?
The other side's next.
But we don't have a hold of that other side, right? I don't know what that is. If I remove rear before I set this previous.
Oh, yeah.
So if I move rear.
It's not a list, we don't know.
If I then, if I say the code is rear.next equals node. Yeah. And then if I say rear equals node, which I want to do because I want to eventually move rear to the last guy, right? But if I do that before I set up this previous, I don't have a handle on this anymore. It's gone. Yeah, you'd have to do some traversal, which is going to be a big O of n, which means you just screwed up this nice method that should be a big O of 1. So you can do node pre equals rear. So I set that up.
Can you also set previous to something so that I
Rear, which if I do this, right? So I'm right here. Now I have rear. Right? So now if I say rear dot pre equals something else, what well, I don't have a pointer to this anymore. Right? Rear was pointing to it, but now I've moved rear, and now I don't know this anymore. I can't say node.previous because we didn't set it up before we moved rear.
So the node, there should be some node, so node does next, that node.
Node.next is null.
Node as in the node before the
Right, but I don't have, what points to the node before? I need a reference to this. And if I move rear, I've lost that reference. I no longer have anything that points to this node. So you can't move rear until you've set previous. So you've got to do it this way. and then we move on. Now, if it's a circular linked list, what do I need to do to things? Rear dot next equals front, right, to maintain the circularity. And then front dot prev equals rear to maintain the front pointing to the end. So we're basically doing a little extra work because we did doubly linked lists, we have to keep track of the previouss. And making it circular just has to make sure that you point the rear dot next to the head, and if it's double, head dot previous to the rear. And what's the big O of this? It's 1 because we didn't do any looping. All we did was create a new node and then move a couple of pointers and rearrange some pointers. And then what I asked for, poll.
Yes, cool.
So we're going to remove the front thing. So again, if front equal to null, or rear equal to null, or size equal to 0. Yes, you could do the remove method. Well, you could do peek too. Because peek will throw an exception, I think. Okay, I wouldn't use the peek, because what if you can stick nulls in your queue? You don't know if it's empty or not. Because peek can return the head of the queue, which might be null, which does not mean that it's empty. It might just have a null stored in the queue. So you could do it, but you got to be very careful. I would actually go with the element that throws the exception when it's empty. Right? And then you can catch the exception and know that it's empty. But if you're trying to check for emptiness, why don't you just say is the size 0, or if the front is empty or null, or the rear is null, the queue's empty.
Why would we have both poll and remove because they both do the same thing, just one goes in exception and the other doesn't?
Well, because we're providing the users of queues more opportunities. Because like I said, if you use the one that doesn't throw an exception, which is poll, when you get a null from poll, what does that mean?
It's supposed to be. It's either holding null.
It's either the queue is empty or the head item in the queue was null, and if you can store nulls in your queue, and you can store nulls in your queue, because null is a valid instance of every class in Java. So if you have a queue of integers, you can stick nulls in there. So if you call the poll method and get a null back, you don't really know if the queue is empty. You're just being told that the front of that queue is null, and poll will return null if it's really null, or it will return null if it's empty. Now, if I'm using a queue and I know I'm never going to store nulls, then when I see the null, I will be happy and I know my thing is empty. Now, if I want to store nulls in it, I may want to use the remove method that's going to throw an exception when it's empty. Right? From the perspective of someone using the queue, you want more options. That's why they have these two methods that basically do the same thing. That's why there's the peek method, that's why there's the element method, that's why there's the add and the offer method. It allows you to do basically the same operations, but when you use the queue, you can choose which way you use the queue. There's nothing that says this queue can't hold nulls. Now maybe in my program that I use the queue in, I don't want to do that. But I have to enforce that. So if it's empty, what do? We return null. Now do I need an else? I don't need an else here because if I go in that if statement, my method's over. So I can then say return value equals front dot data. Front equals front dot next. Now, if it's a circular queue, do I need to update front dot previous? No, because front, actually, I do now, right? Because if this is front, and it's doubly linked list, if I move front, which I just did, what does front dot previous point to?
The old front.
The old front. What is it supposed to point to?
Rear.
It's supposed to point to the rear. So front dot previous equals rear. And what have I forgotten to do? Size. Oops, minus minus, and then return value. Do I have to do anything else? What have I forgotten to do? If it's a circular, yes. If it's a circular queue, rear dot next points to the old front. I need to update the rear dot next. Now these two lines of code are only here because it's a circularly linked, if it's circularly linked. If it's not circularly linked, you don't need it.
So, assuming null is a valid value inside of your queue, the only way to really check for emptiness would be to check the size?
Size or front. See, front does not point to an E, right? Front points to the link node. So this link node this could have null in it.
Oh, so front.data becomes null.
Right.
Front itself is.
No, front's not null. Front.data is null. So I can store nulls in my queue. Right? The front.data is going to be null. If I have an array of type E, this could be null. Well, what does that mean? Does that mean that the queue is empty? That because front or data sub front is null? Does that mean it's empty?
Not necessarily.
Not necessarily. If size equals 3 and data sub front equals null, that means that you got a null in your queue.
So if it was an array, you'd have to check the size value.
Yes. Well, the array, you need to check the size value, and then there is some math you can do on front and rear, because if front and rear are off by 1, depending again how you count, is front pointing, or is rear pointing to the next empty spot, or is rear pointing to the last filled spot? You can do some math. Because if front and rear are pointing to each other, and basically I would just do it by size. If size is 0, then it's empty. Because it's what you got to figure out the math. Because it's circular, right? So front could be here, and rear could be here. So if you subtract the two, you got to mod it by the size or the capacity. But basically, for the array, use size. For the linked structure, the reason you can check for null is that when I instantiate an empty one, front and rear are null.
Front rear, null. But when you add nodes to the data references inside each nodes, can be null.
Now the question, though, well, it's because the one thing that we do have to check here, right here, is we do want to say, to be better, if front, what do we need to do, or what should we do? We want to say rear equals null. Because if we only had one item in the queue, we update front, and if it's singularly linked, front will now be null, because it fell off the end. So you got, this is if front equals null or size equal 0, right? Because we want to make sure that rear gets back to null. Get back to our base case of when we have an empty queue, front and rear are null, and the size is 0. So we probably want to do this, we should probably do this to be best. Because this will work whether it's a circularly linked list or not. Because if it's a circularly linked list and you had only one item in it, where does front go? So what do? We say front equals,
Trying to do poll right now?
yeah, we say, we get the return value, whatever it is in here. We remember that. Then we say front equals front dot next, right? So where does front go?
Back to itself.
Back to exactly what it is. Doesn't change. We then say front dot previous equals rear, which doesn't actually change anything, and it's still circular, but our size is now 0. But by the pointers, it looks like we have one thing still in it. Because front and rear are still pointing to something. So we need that if statement to say if the size is 0, we need to set them to null. If it's a circularly linked list. If it's not circularly linked, then when you say front equals front dot next, that would be null, indicating we're at the end, and therefore you now know that front is null, and therefore we need to still set rear to be null, because rear will still point to that old bad node. So there is that boundary case. So if you're removing the last item in the queue, you need to set the queue back to its state where it is empty. Questions? Okay. Again, not as a negative thing, Friday's the last day to drop. And you gotta get all your paperwork in by 4 p.m. Homework's due on Friday. Please start the recursion stuff on the weekend and come to class on Monday with questions. Thank you.